Okay, let's continue with the dot products. And I believe I ended the last lecture with the following definition. If you have u dot v, if you have two vectors, the dot product between the two is, you take the norm of the first times the norm of the second, and you multiply it by the cosine of the angle between. So theta is the angle between the two vectors. And I explained how this formula implies that if two vectors are perpendicular, it's going to give you 0, because perpendicular means 90 degrees and cosine of 90 degrees is 0. And also that if you have anything with this self, then that's like norm of itself squared times cosine of the angle 0, because the angle between a vector and itself is 0 degrees, right? So that implies that you end up with the norm squared. And that's true for any vector. If you have any vector dotted with itself, it will be the norm of that vector squared. The magnitude of that vector squared, because cosine 0 is 1. So these two are direct consequences of the fact that cosine 90 degrees is 0 and cosine 0 degrees is 1. All right. And I explained why that the two important property that u dot v is equal to v dot u, commutative property, implies, and also u dot v plus w, which is the same as u dot v plus u dot w. This is the distributive property. These two properties enable us to calculate the dot product of any two vectors when their coordinate forms are given. Okay? All right, so that was what we covered last time. Let me now extend this further to dimension 3. Okay. In 3 dimensions, you use x, y, and z. And what's the definition of I? I is the unit vector. This hat here means it's size 1, length 1. It's a unit vector in the direction of the x-axis, right? And if I say that, let's say this is x, so x, that will be I, j will be this direction. In 3D, the height information is given by the z-axis, and the z-axis has this unit vector, which we call k vector. Okay, so k vector is what we call the unit vector in the vector in z-axis. Okay. All right. So let's do a little bit of exercise with this k. What will be I dot k? What's I dot k?
0.
0, because I, the x-axis, k, the z-axis, has 90 degrees. They're perpendicular. Therefore, because of the same reasoning as this, it will be 0. How about k dot k?
1.
Will be 1, right? Oh, by the way, this unit vectors have length 1, so it will be 1. Okay? This will also be 1. Okay. And there's a few others, but I don't need to write them. It's like j dot k will be 0, and I dot j will be 0, j dot j will be 1. I don't have to write them. It's kind of obvious now, right? Okay. So using that, let me try to figure out the formula for dot product of two vectors. So let's try to work out the formula for dot product of two vectors. So let's say vector u is a comma b comma c, and vector v is d comma e comma f. Three numbers each. So these are three-dimensional vectors. Now, you can represent any three-dimensional vectors by using I and j and k. Let me explain how we do that. First, think about it as a comma 0 comma 0 plus 0 comma b comma 0 plus 0 comma 0 comma c. You can certainly rewrite a comma b comma c as this, because a plus 0 is a, 0 plus b plus 0 is b. So if you add them all together, you get this. Okay. Now the first thing can be written as a times 1 0 0. The second is b times 0 1 0 plus third one is c times 0 0 1. What is this vector? 1 0 0.
I.
It's the I, because it's only going one step towards to the x-axis, right? So that is the unit vector in the x direction. So that's I. So you can rewrite this as AI. I decided to just use I plus, how about this one?
J.
J, right? So it would be Bj, and then the third one will be Ck. And likewise, you can rewrite V as D, I, E, J, F, K. And then let's try to figure out what this will be. U dot V, that's not a unit vector, it's a vector. U dot V is like doing a dot product between A, B, C, dotted with D, E, F. And then you FOIL, right? So this first thing that gets dotted with each individual ones, because of this distributed property. You're distributing each element from the first one to every element to the second one. So this gets multiplied to this. You're doing dot product individually. Okay? So you have a total of 9 possibilities, right? But I don't want to write them all, because we can kind of figure out just mentally, we can just calculate mentally, right? Just, what is AI dot DI? What would I dot I give you?
1.
1. It will be 1, right? I dot I is 1. So what do you get?
AD.
AD. Okay. What's AI dot EJ? What's I dot J?
0.
0, because I and J are perpendicular, right? So that'll be 0. What's I dot K?
0.
0, because again, they're perpendicular. Now let's go to B. What's BJ dot DI? 0. 90 degrees. What's BJ dot EJ? BE, because J dot J is 1. What's BJ dot FK? J dot K is 0. And then what's CK dot DI? 0. CK dot EJ? 0. CK dot FK? CF. And therefore, we get the formula AD plus BE plus CF. Okay. So we derive the formula, but if you just look at the formula, it's very easy to remember. What's the dot product of two vectors if they are given in coordinate form? You simply take the pairwise product of corresponding components. So x component times x component, y component by y component, z component by z component, and you add them up. That's how you get the dot product. That's what this formula is saying. Okay, is that good? All right. Now, can you think about what will be the formula for two-dimensional ones? What would be the formula for two-dimensional ones? If you have A comma B dotted with C comma D, what would you get?
A, B, C, D. Or
Yeah, AC plus BD. For the same reason. I mean, you would be writing this as AI plus BJ dot CI plus DJ, and then if you just do the FOIL, you'll see that everything will, two terms will die off and two survivors will be just AC and BD. It's that simple. So that's how you do the dot product. So let me write these formulas so that we can quote it later. D, E, F. Having two different means to calculate a single object gives you lots of results. Let me just first ask you a simple question. If you example 1. Suppose vector 1 comma negative 2 and 5 comma A are perpendicular. Sometimes called orthogonal. Okay. Orthogonal, perpendicular, right angles, all the same thing. Okay. What is A? So let's think about this question. Now, what does this have anything to do with the dot product? What does dot product have anything to do with perpendicular?
that means it's 0.
If two vectors are perpendicular, they're 90 degrees, so you know that their dot product is 0, right? So we know that, so solution, we know that 1 comma negative 2 dotted with 5A should be 0. So let me write down what I'm referring to here. Note, U vector and V vector being perpendicular is same thing as U dot V is 0. Okay? So if two vectors are perpendicular, you know that their dot product is 0. If two vectors dot product is 0, you know that they're perpendicular. It's vice versa. It's a very important note. And this is the property that we're using to solve this. Okay, then, once you know this, then we can use this formula here. Okay, so what do you get if you explicitly calculate the left side?
5 minus 2.
1 times 5 plus negative 2 times A. That's what you get on the left side, right? Because you have to do pairwise multiplication, and you have to add it. And then that has to equal to 0. Let's see, this is 5 minus 2A equals to 0. 5 is 2A, therefore A is equal to 5 over 2. Okay. So that's how you solve this question. Could you press it?